And welcome back. In this lesson, we're going to be looking at the z-test for one mean, also called just the z-test. In this hypothesis test, we are comparing the population mean to a constant value. And throughout this lesson, I'm going to be using this example as to help motivate the formulas and where they come from and why they work the way they do. So in this example, and I hope you'll pause the video to read this real quick. In this one, we want to know, did household energy bills increase during the pandemic? So we've got this value that we know they were before. So this is going to be our hypothesized value. So this is what we're calling mu naught. Oh, would help if yeah, okay. So this is mu naught. I'm having trouble with my mouse pin here. Okay, so mu naught, this is our hypothesized value. This is what we want to check against. And this mean here is based on 100 households. So this is going to be our sample size, and this is our sample mean, and this is the population standard deviation. But what we want to know, and this is going to be our alternative hypothesis, is did household energy bills increase during the pandemic? So let's set up our hypotheses to start with. I always like to write the alternative hypothesis first. And what I mean by that is you always list the null hypothesis first. But I like to, once you set up the alternative, the null follows from it. So what we're looking to prove, not really prove, but can we conclude that this mean increased from when it was $73 a month? All right. So that's our alternative hypothesis. And what we're going to assume, unless we can show otherwise, is technically that mu is less than or equal to 73. But we're never really proving H naught anyway, or we're never concluding H naught. And how do I say this? Let's just go with that for now. We're never really concluding H naught anyway, so let's just assume that it's on the boundary there. So usually you'll see the null hypothesis written as an equal. All right, so these are our hypotheses for this problem. And we're looking for how to calculate the p-value. And remember we said in the last video that the p-value is the probability of rejecting H naught given that H naught is true. So if H naught is true, in other words, that mu equals 73, and this is actually the other reason we list that as equals instead of less than or equal. So in other words, if mu equals 73, what is the probability that we get X bar greater than 78.25? And we know how to find this because we did this during when we were doing sampling distributions. And to do this, we use this formula, z equals x bar minus mu over sigma over the square root of n. So when we do this, this gives us the probability that z is greater than x bar, which in this case is 78.25, minus the hypothesized value, which was 73, over sigma, which in this problem was $18 per month, over the square root of the sample size, which was 100. So that's the probability that z is greater than, and I need my calculator here. So 78.25 minus 73 divided by parentheses 18 over the square root of 100, so just 10, but if you want to do this in Excel, I'll show you the full steps. You don't have to use Excel, you can use any calculator you want. So that is 2.91667. So we'll round that to 2.92. And we need to be able to find that formula, or that value. So to find that, we need our z table. And we found, let's see, what was that value that we're looking for? We're looking for the probability that z is greater than 2.92. So the probability that z is greater than 2.92 is the same as the probability that z is less than negative 2.92. And you can verify that. So that is 0.0018. So this is our p-value. So we talk about something else called the test statistic. The test statistic is this calculation for z. So the test statistic is really just a step on the way to calculating the p-value. So now that we've seen where that formula comes from, I feel comfortable to tell you that the test statistic is calculated using this formula, and we really should put mu naught there. So x bar minus mu naught over sigma over the square root of n. That's our test statistic for this hypothesis test. Every hypothesis test has a different test statistic and p-value formula. And I put z star just to distinguish that from the values on the z table. We're comparing, this is just the specific value of z we're comparing to. And so we found that in this example, we were looking for the probability that x bar was greater than. If this example were less than, then this would be less than as well. Therefore, if your alternative hypothesis is less than, then your p-value formula is going to be the probability that z is less than this test statistic. And then this second one is the one we just saw. This third one is, this one, by the way, this is the absolute value here. Basically, we're going to end up, for the less than alternative hypothesis, we're going to end up rejecting H0 if the sample mean is far enough below the hypothesized value. For this alternative hypothesis, where mu is greater than mu naught, we're going to end up rejecting H0 if the sample mean is much greater than the hypothesized value. So if it's farther out in the tail to the right. For this one, we're going to reject H0 if the sample mean is too far away from the hypothesized value in either direction. And so for that situation, we have to take the tail area and multiply it by 2. If you don't understand that, don't worry about it. This one is a little bit harder to understand, so as long as you can do this, that's okay. So I just need you to know that you take the absolute value of the test statistic, find the area to the right, and multiply it by 2. We'll see an example just like that in a minute. Couple more things before we do our first example all the way through. Just to emphasize again, if a probability is unlikely, that means it's a small probability. The way we define a small probability is we set this value in advance that we call the level of significance. And the most common value for the level of significance is 0.05. You may also see 0.01, occasionally 0.1, sometimes 0.001. But regardless, the point is, no matter which one of these alternative hypotheses you're working with, you're always rejecting H0 if the p-value is less than that defined level of significance, which we call alpha. That's a lowercase Greek letter alpha. Okay? And again, regardless of what direction that is, we're always rejecting H0 if the p-value is less than alpha. Okay? Or the level of significance given in the problem, which is usually 0.05 or 0.01. More on that in a bit. So we said this before, but again, we're emphasizing things today so that we make sure everybody gets them for the rest of the semester. For every hypothesis test, you either reject H0 and say that there is sufficient evidence to conclude that whatever the alternative hypothesis says, or you fail to reject H0 and say that there is not sufficient evidence to conclude that whatever the alternative hypothesis said. Okay. I should mention here just a little bit of language. We refer to this alternative hypothesis, the not equal to situation, as two-tailed. for the reason I mentioned earlier, and we refer to these other two as one-tailed. Okay, just keep in mind that two-tailed means the alternative hypothesis is not equal to. One-tailed means it's less than or greater than. And then one other thing, statistical significance. I mentioned earlier that the term statistically significant is the same thing as rejecting H0. So if you reject H0, you say that the test is statistically significant, or that this mean is significantly higher than whatever your hypothesized value is. I'll also mention there's another way that you can use the language there. Suppose you have a p-value of 0.025. It is correct to say that the test is significant at the 0.1 level. It's also correct to say that the test is significant at the 0.05 level. It's also correct to say it's significant at the 0.03 level. And at the 0.025000001. All of those things are correct. However, this is usually stated as the test is significant at the 0.05 level. Usually that's how you'll see that. What they'll usually do is state that as the smallest common level of significance. So among 0.1, 0.05, 0.01, 0.001. So usually that's how that'll be phrased. And there's just one more thing I'll mention before we sign off on this video, and we'll let you do some examples. If on some computer output sometime you'll see that does not mean that the p-value is exactly 0. It means that it's 0 rounded to 3 decimal places. And we usually just write that as p less than 0.001. So instead of, once we get to doing some problems in SPSS next time, if you see p equals 0.000, just list that as p less than 0.001. And you can say that's significant at the 0.001 level. All right, so this video is getting a little bit long-winded, so I will cut this off for here and we'll make a separate video with the examples. So I hope that right now you will, before you watch the next video, go to the skeleton notes and get the 3 examples and try at least the first one, or maybe watch the first one, see what that looks like. Try the second one before watching the solution. All right, so stay tuned for part 3.